I'll just start by saying AM uh, tower lights, AM transmitters have been the big power consumed for many stations. And here is an opportunity to find a way to cut that down a little bit or a lot, depending upon your facility. And so I'm real happy to have Tim Hardy, who designed the MDCL originally for Nautel, and Rich Redmond. They're from BE and they're going to talk to us about an interesting way in which whatever transmitter you have, you might be able to make these savings happen on your site. So I don't know which of you guys want to start, but floor is open.
Okay. Well, I'll make a brief introduction and then Tim can get into the meat of it if that's okay.
Absolutely.
So thanks for having us, Barry, and good seeing everyone again today. So, sometimes people ask about, geez, how do you come up with ideas for products? And I have to give credit where credit's due on this one. It was not this NAB, but a year ago, I was having breakfast with one of our sales guys and Martin Stabbert from Town Square, and we were talking about what kinds of things, where are the problems? What problem solvers are you looking for? And Martin said, geez, I did MDCL on a 50 kilowatt transmitter and it worked great, and I can always make the numbers work on the high power, but the cost to go implement it on low power is a lot harder because with some guys you have to go buy a completely new transmitter, uh, and we've got a lot of solid state transmitters that work pretty well, and with other guys, the cost to do it at the lower powers, even if I could put it with an existing rig, the payback's awfully long. It's hard for me to spend my money on that. And so we kind of noodled around about it, and I eventually came back, and Tim and I had some discussions and talked with the design guys and said, geez, this shouldn't be as complex as it needs to be. And so, or that it has been, rather. And that kind of led us down the path. A lot of times product ideas start with what's the problem you're trying to solve that someone has, and once you define what it is, you usually can get off and running on a solution. So uh, we were pretty excited this year to bring what we're calling MDCL Plus, a small audio and logic control box that will work with all the BE transmitters. And Tim can talk a little bit more on how it could be used with late model transmitters from other suppliers. Um, but it really hits that target. It's pretty simple to put in audio in and out, and a little bit of setup, and in some cases a slight mod of a transmitter. And you can achieve some really significant power savings on transmitters that may be very reliable and otherwise fairly efficient, but are 5, 10, 15, 20 years old. Um, so that's kind of how we got here. And I'll let Tim kind of take you through the specifics of kind of the concept and a little bit more about the solution.
Tim, would you like to have questions held until you're done, or would you like folks to pipe in?
No, I think pipe in anytime is good with me.
Okay, so that's the alternate A or the space bar if you have a question while Tim's going. So carry on. Sorry to interrupt.
Yeah, no problem. So, okay, thanks very much, Barry, for sharing your platform with us. Let me just share my screen because I did pull together just a few slides to help. Here we go. Help with it. Can everybody see that?
There it is.
Okay.
Yep.
All right. So, and let me just go to the next slide. Hopefully that should just. There we go. So obviously the topic is MDCL Plus, which, as Rich mentioned, is a new product that we introduced at NAB this year. And most people here will be probably familiar with MDCL, but just, to give a little background for those who may be less familiar, what is the technology? The idea basically is that you want to reduce, there are times where you could potentially reduce the carrier power from your transmitter as a way to reduce energy consumption. People have sort of been thinking about this for a very long time. And MDCL, the name, is actually a fairly recent name that was coined with the NRSC in the US in the last, let's say, in the last 10 years. But the technology is actually much older than that. It goes back to the 1980s, and there were several different initial versions that were developed, one by the BBC, one by Telefunken in Germany, and one by ABB in Switzerland. And they were all, these were either manufacturers or operators of very big transmitters, 500 kilowatts. And of course, the energy crisis was happening, and the cost of the power was tremendous. So they were really looking for a way to do this. And the engineers are saying, well, this carrier is there all the time, and it doesn't carry any information. So can we reduce the carrier at certain times? And initially, some of the technology did just that. It only reduced the carrier power. And there are several different names of technologies that focus only on the carrier. But what ended up being, let's say, what's commonly agreed to be the best technology was the version that was developed by the BBC, and it's called amplitude modulation companding. And it reduces both the carrier and the modulation, which actually ends up making a little more sense. But we're just using this generic term MDCL because that's what's now the most familiar term for most people. But for those of you who understand things a little better, this is really running AMC, amplitude modulation companding. So how does it work? Well, effectively, you've got this small box, one rack unit. You just put it between the audio processor and the transmitter audio input. And of course, there's a setup and adjustment that you have to do on the first day, let's say. What is it compatible with? Well, generally all transmitters, all AM transmitters since 2001, certainly those manufactured in North America, were compatible or were upgraded to be compatible with HD radio. And part of the changes that were made at that time for HD radio compatibility was to allow the audio input to be DC coupled. Most typically, if you're running AM, no HD radio, you would AC couple your audio input, meaning that there's a high pass filter there. But for HD radio, typically there's a set of jumpers for HD radio compatibility that eliminates that high pass filter. And that's really the thing that we're making use of. We need that DC coupling of the information coming into the audio input. Now, with older AM transmitters, pre-2001 approximately, you can simply do that. You may not have the jumpers, but you can just bypass that high pass filter. Typically, it's just a single capacitor in the audio chain or two capacitors in the audio chain. They can be fairly easily bypassed if you're willing to, get out a soldering iron. So what are the benefits of MDCL? Well, the goal here is to save electrical energy cost, and we typically see, let's say, 30 to 50%. Some people report more than that, but I would generally say conservatively you'll be in the 30 to 50% reduction in energy use. And of course, that goes straight to the power bill. No noticeable effect on audio performance. You can configure how much, we use the word compression to say how much the power is being reduced. And typically people operate 3 to 6 dB of compression. And if you're at the more conservative end of that, around 3 dB, it's very difficult to hear any difference. At 6 dB, some people say, okay, I can just start to hear what's happening, but it's not significant. So generally we say the effect on audio performance is very limited. Where are we today with the status of the product? So essentially we're finishing factory testing, and we're hoping to get the first field trial up and running very shortly. And we're currently accepting orders for the product as well. So here's a quick block diagram of again, what I was just saying. Basically, the box sits between the audio input, between your audio source, from the audio processor, and the audio input of the transmitter. And of course, the difference is that the MDCL processor will add a DC component to your audio. And that DC component, after the transmitter is configured to be DC coupled, that will essentially allow the MDCL unit to reduce your carrier power and also reduce the audio at the same time. So as I mentioned before, the technology that we're using is the AMC technology. That's what everybody has sort of agreed is the most appropriate, or let's say best. And when we do that, we turn down the audio level and we turn down the carrier level together equally. So loudness is not affected because, you know, it's essentially as if you were turning the power down on your transmitter. You know, a little more background maybe for a moment. The idea is that when your audio levels are loud, so when you have large, higher modulation levels, you are much less able to hear background noise. You know, this is masking, which, you know, perceptual things going on that your ear, you just can't really hear noise very much when the audio is louder. So by keeping the audio and the carrier level high when the modulation is low, we maintain the same your normal signal noise ratio. And then we allow that signal noise ratio to be reduced a little bit, but only when the audio is louder and you can't hear it. So that's kind of shown here. This is the characteristic curve that is defined by amplitude modulation companding and the curve with which this unit works. So essentially, once you've set the unit up, you can choose how much compression you want. And this shows, you know, 1.5 dB, 3 dB, up to 6 dB of compression. And essentially, you've got on the x-axis, you've got your audio level up to, you know, 125%, and then on the y-axis, you've got what's your transmitter operating power. So you can see that for low audio levels, the transmitter power is unaffected, let's say up to 10% audio. And then as the modulation increases, it just proportionately reduces your transmitter power. And the higher you set the compression level, the more it's going to reduce your carrier power. So typically people would operate between, let's say, the 3 to 6 dB range. So, you know, conservatively, you might start with 3 dB of compression. And that means that with 100% audio levels, your transmitter power is going to be reduced to half, 50%. And if you run it, you know, with more compression, trying to save, you know, additional electrical costs, then you could run at 6 dB, in which case it's going to reduce the transmitter power all the way down to 25% at 100% modulation. So that's essentially what the unit does. Examples of cost savings. You know, you just calculate, you can fairly easily calculate the electrical costs of a transmitter. If you know your electrical rates, you know the efficiency of the transmitter. So these numbers are based on a transmitter which is 75% efficient. And if you had, for example, a 10 kilowatt, which was running 24 hours, 7 days a week, with a 20-cent electrical cost, it should cost you around $25,000 a year for electricity. And if we put you in the middle of that range of 30 to 60% or 30 to 50% cost savings, you would save $10,000 a year. Obviously, that's going to scale. If you operate at less hours per week or at lower power levels, you're going to save less. So obviously, it depends on what your actual electrical costs are. Now, okay, setup, just quickly running through what would you have to do if you purchase one of these units. Most of the equipment you would need, you would already have. Most people are going to have this at the radio station. So ideally, you'd have a dummy load. Sorry, did I hear? Is that a question or no? Most people are going to have a dummy load. You should have a modulation monitor, an audio source. So typically, your audio processor will allow you to set 100% audio, a modulation as a tone. So your audio processor should do that. and you're going to need a current meter because you want to see what's happening with your power levels. The wiring is simple, as I showed before. You just need audio in and audio out. Well, and the unit's going to add that DC component in. And then the part that depends on your transmitter is configuring it to accept DC on the audio input. That's the part that depends on your transmitter. If it's a newer one, you're probably just going to have to change a few jumpers in the exciter. And then the part that depends on your transmitter is configuring. Oh, sorry, I'm hearing myself there. Okay. Then, yeah, with an older transmitter, that's where you'd have to get your soldering iron out to bypass that high pass filter that's there. Then once you've got it all set up from a hardware perspective, there's a calibration procedure, and there's essentially 4 adjustments in the unit. One adjustment is just the audio gain, and you just want to confirm that the audio levels in and out have not changed. So there's an adjustment there to make sure of basically unity gain through the unit, 0 dB gain. There's a peak measurement so that you confirm that the unit reads 100% on its front panel when you put that 100% tone through. So you're essentially setting the unit so it can properly measure your audio levels. And then there's 2 DC adjustments. There's essentially a fixed level, and we call it DC offset. Basically, that's a level that's going to bring your internal carrier power to 0. And then there's a DC carrier level. These are normally equal to each other. It's just one of them is going to vary, and the other is a fixed level. So once you've set up those 4 things, then the unit should be ready to run. And you've just got 2 operational settings. One is that compression level we talked about. Typically, you might start with 3 dB, and other people might go straight to 6 dB because they know that, they've talked to other broadcasters, let's say, have had good results at 6 dB. So that you can adjust that to whatever level you want. And then there's a time constant, which is essentially how long does the unit take to recover your carrier power? Traditionally, the guidance was to set that around 200 milliseconds. I know that today some people are setting it a little bit longer to 600 milliseconds based on more recent results. And so that might be one that you could do a little bit of research on, but it would typically be in that 200 to 600 millisecond range. So those are the 2 adjustments you have. And that's basically it. You can install the unit, calibrate it, and set it up quite easily in a day. Older transmitters I was just mentioning. So I just threw up a couple of schematics here. I'm very familiar with the Nautel products. So AmpFet was the original Nautel AM, and they have 2 blocking capacitors in the audio input card, and essentially you would just need to bypass those 2 capacitors. That's pretty easy. Similarly, this is a DX50 input schematic on the left, and it has a pair of 2 capacitors there in parallel on each side, on the audio plus and audio minus. So you would just have to bypass one of those on each side. And that's basically it. So the amount of work to configure an older transmitter is very limited, really. So it's quite easy. Should be quite easy to do. There are some transmitters, we haven't tried this on all of them yet. And the more analog your transmitter is, so for example, that AmpFet, there's no software anywhere in there. That one is going to behave very predictably. We're talking to somebody who has a 4MX transmitter, and there's a bit of software in there somewhere. So we need to do a test to confirm that the 4MX will do that. But I know there's not very many of those out there. The more recent DX, the DX3 Destiny transmitters, they should definitely be compatible. Again, we haven't actually tried it yet, but I don't expect any difficulties there. So, so I'm pretty optimistic that all these older transmitters will work fine.
I think we need a little
So
better definition of older.
Sorry, could you repeat that?
Yeah, I think we could use a little better definition of older, because I come from I started in the 70s. I'm pretty sure you couldn't get that plate modulated columns to do this.
Yeah, so tube transmitters, it will depend on the topology, right? So any transmitter, I'm not somebody who spent a lot of time working on tubes. I've worked with linear amplifiers a little bit that were tube type, but if you have a transmitter that the carrier power gets to the final tube through a choke, and then the audio power comes in through a capacitor, essentially AC coupled, that would not be compatible. All right. But basically any transmitter, so there are some tube transmitters that are, I believe the correct term is, I hesitate to use the term because I'm not sure everybody agrees on what it means, but plate modulated, to me, we use that term, plate modulated, essentially means that the power supply to the final stage carries the whole envelope, the DC of the carrier plus the audio. So any tube transmitter that works that way would be compatible. All right. So I'm mostly familiar with international, very high powered tube transmitters, and some of them had solid state modulators on a tube final. They would all be compatible with this technology.
So maybe to add a little bit of color, like the DX series from Harris, was debuted in 1988, so about 36 years ago. So I would say, as a rule of thumb, that vintage transmitter and newer, and so the DX line worked with a version of ACC for carrier control, and Tim's pointed out the amp FET. So I think really, if we're thinking about it, while maybe there's a tube rig that could be made to work, that's a little bit more of a science fair project. But a 35-year-old solid state transmitter's a pretty good candidate.
I think that the just an aside, the Continental shortwave rigs, I believe, have this built in because their digital step modulator actually plate modulates the final, but it's a digital modulator.
Yeah.
So I think
It's a
that
step.
actually works. However,
Yeah.
something that uses a transformer between the modulator and the final, I would say no go there.
That's right. I agree. Yep.
Yeah, I mean, we did have a customer who at NAB we were meeting with, if you remember, Tim, wanted to know if it would work with this plate modulated RCA transmitter. And while, it might be an interesting science project, I think our suggestion was there's probably more gain to be had by getting something a bit more contemporary. It's pretty expensive if you can even find tubes these days for that.
Yeah.
Well, I would think you could even go as far as the BC1H because it had the solid state modulator in it.
Yeah, anything that's, I guess I agree with what Rich is saying, but if somebody wanted to try it, as long as the DC of the carrier and the audio are coming from the same place, the DC parts of the envelope essentially is plate modulated. If they're coming from the same place, it should be doable. But I mean, the way this really, your audio input brings the carrier to zero normally, right? So all we need to do is have hardware that allows the DC carrier to hold it down, right? If it's AC coupled, anytime the audio is negative, you have to have an equal positive time. Otherwise, you have a DC bias, right? So essentially, as long as you can pass DC through that audio chain, it'll work. That's the fundamental requirement. So the test that I've told people, a few people who called up with an unusual, I guess one person in particular, is if you bypass those capacitors that I'm showing on the screen right now, then all you need to do to try this is take a power supply with an isolated output that's variable, like a lab benchtop power supply, feed it into your audio input, and confirm that you can turn your carrier power down with DC. Right. So if you can do that, then it'll work. So it's a quick way to check it.
Tim,
Yeah. Hi, Ben.
I have a couple comments I'd like to make, but most of if perhaps not all of the Doherty transmitters can be made to work with MDCL of the British style. They had quite a few Doherty transmitters that they were using that were made by Marconi that they were using AMC on before even people started using it on shortwave transmitters. But the couple comments I wanted to make, because we were involved with MDCL very, very early on, because we got the FCC to approve the first experimental use of it up in Alaska. Lots of folks have talked to us about it over the years, and we've had two kinds of situations where the use of MDCL has been an operational problem or operational solution. The problem was that in a couple of places where there was appreciable audience in fringe areas and incoming interference levels that were high, South Florida, there have been a couple of cases where people actually documented that MDCL at anything more than a dB or two was detrimental to received audio performance. But they're very, very limited cases. And the other instance is we have one client, in fact, who operates MDCL on a transmitter to keep the antenna system voltage levels as low as possible because they've got an antenna system that for local political reasons can't be rebuilt and gives them voltage handling problems. And MDCL solved that very nicely.
Yeah,
I'd like
well,
to comment, if I can, that with KBLA in Los Angeles on 1540, we put in a Harris 3DX50 that had the MDCL built into it, and we turned that on. It seemed to be working great. Power savings were looking pretty good, but we found in the morning we had complaints from listeners that the station was being interfered with by a co-channel over in Arizona. So the end result was we had to turn off the MDCL to keep the carrier up to keep that interference suppressed. So that was one case where it didn't work out too well for us. New ownership has taken over there and things have changed. So maybe now they can turn the MDCL back on, but I've retired, so I'm not involved with it anymore.
The station in Arizona is now off the air. The FCC just revoked their license last week.
It's a different 1540.
No, KSA Phoenix.
Oh, this is Los Angeles, though.
But the one that
No.
was interfering that Marvin was talking about.
The interfering station. I'm sorry. Yeah.
Oh, you mean
Done.
that one's been shut down?
All God.
I'll be darned. So that's the one over, I think it was what, in the Tucson area?
Phoenix. Just
South
under
Phoenix
South
area?
Mountain.
On 1580, they shut it down, huh?
1540.
Oh, well, that's not the co-channel, and I think it was the 1580 that was our problem.
You said 1540 earlier.
Yeah, I used to work at 1540 here, so I made a mistake. Sorry about that.
Occurs to me that the old Western Electric transmitter, 1943 vintage Doherty, has a grid modulated driver. I'm just kind of thinking, with a little work, you could probably do it with that one. By the way, I have a question because I've heard a couple different opinions. Is
As a grid
MDC
modulated driver.
Yeah, it's and when they had a problem with the drive control, it just sort of it's behaved very strangely. The modulation kind of stayed there and the carrier dropped. So that was partly why I was thinking, gee, I wonder if that one could. Anyway, that's a whole another conversation. But I'm just curious what you would say, because I've had differing opinions about whether MDCL is compatible with IBOC digital hybrid AM digital operation or not, yay or nay.
I do recall some discussions about that. I mean, this hardware would not be. And of course, most AM broadcasters now, I think, are looking more towards all digital, and it wouldn't be applicable to all digital HD radio. So hybrid HD radio, I think probably you could get away with it. They don't really use the carrier amplitude in a hybrid system for much, so it wouldn't. In fact, the NRSC right now is looking at reducing looking at studies, let's say, or analysis that has been done on the effect of reducing the carrier even in the MA3 mode, because MA3 all digital still maintains a large carrier in the middle of your spectrum. So they found that reducing that carrier by, let's say, 3 to 6 dB has relatively little effect. So I would assume, and it's just that, my assumption, that MDCL with the HD radio would be fine in hybrid MA1. The thing is, you'd have to get the hardware to do it. So this unit would generally, I don't think, I'd have to think about that. Maybe it would work, but I don't think so. Yeah, we wouldn't recommend hooking this up between a analog, you know, a Gen 2, old Gen 2 exciter, even if you could find one or get one made for you. So this hardware would not be designed for that.
Also, just a comment, the currently hybrid, the MA3 is only going to be on low power because nobody's building transmitters yet in the higher power levels that will accommodate the MA3, as I understand it.
Oh, any transmitter today will do MA3. The question is whether or not the mask is compliant. I mean, that's what you've always got to worry about with any of these digital standards when you take a transmitter and for the first time, let's say, and run these signals through them. It's all about spectral regrowth. But any modern transmitter built today will run MA3, provided you can give it the correct inputs, right? So most of the transmitters, with the exception of Nautel's NX, require, you know, external mag and phase inputs, which are essentially analog signals to drive them. So if you can find an exciter that will give you those mag and phase signals, any modern AM transmitter will run MA3. But you'll still be looking at, you know, does it run it well enough to maintain mask compliance? That's always the challenge.
MA3 still uses a large carrier. I thought the carrier kind of went away with MA3.
It's not as large. It's not, you know, if you run 50 kilowatts. So you know, if you have a 50 kilowatt AM station, you run obviously with AM analog, your carrier is 50 kilowatts, and then your side bands, you know, depends on how much modulation you have, 5 or 10 kilowatts maybe. When you convert to MA3, your total average power would be 50 kilowatts, and a portion of that power would be used in a large carrier in the middle. And when I say large, I just mean it's larger than any of the subcarriers. It maybe represents, don't quote me, 10 or 15% of your total power, unlike AM, where it would be, you know, 80% of your total power, let's say. So it's large from that perspective, that it's bigger than the other subcarriers, but it's not as big as it is with analog.
If you can't dynamically pull the carrier down, that would be a problem, probably.
Well, they were doing testing to see how far they could reduce it, because they do use it in the receiver. And they were doing some tests, and I think the answer was 3 dB is fine. And that probably will go forward, that we'll just decide that we can reduce that carrier by 3 dB. And then maybe around 6 dB, they started to see some negative effects on reception. So,
okay. Yeah, this is way off topic, and I apologize, but we do have a hybrid IBOC in town that's running an XL series. And they were told, I think, that one could not do MA3.
Well, that's part of the problem, is that MA3, it's back to the exciter, I think. I mean, Nautel will say what Nautel says, but there's nothing technically that will prevent an XL60 or whatever it is, XL12, to run MA3. You know, again, I'm very familiar with those transmitters, having worked on them for 23 years. But the problem right now is that we're sort of in a transition period for the manufacturers, where we need to build some new HD radio AM exciters, which are specifically built for MA3. So I think it's more of an exciter issue than it is a transmitter issue.
Okay, thank you. I'll now return you to your regularly scheduled topic.
So I had two questions.
Okay.
How you doing, Tim? The first one you mentioned on the Harris, on the DX50. I don't have any 50s, at least down on the East Coast. On the West Coast, yes. I have mostly DX10s and BEs. So you said you only had to remove one cap from each side. Why not both? Was there a reason you said specifically one?
Well, if you shorted one, you've effectively, from a topology perspective, you've shorted them both out. So it doesn't matter if you put a capacitor in parallel with a wire, you still get a wire.
Yeah, no, I was like, okay, which one do I choose? So, the other question was like I said, a lot of them are BEs, AM5s, AM6s,
Yeah.
AM1s, couple of AM10s. So
Yeah.
those don't have any outside source to really I don't know why it's popped up.
So that they have an audio input, obviously, and if they're built since 2001, they would have jumpers that essentially allow you to just move a jumper from, position 1 to 2 to short out capacitors in a similar way.
Right, but how do you get the DC into it? That was where my question was going.
Well, the way it works, so just backing up a little, if I go up to that screen there, you have an audio input on your transmitter now, which is differential. It's 2 wires, right?
Right.
That's going to be when you install this system, those 2 wires are going to carry audio as they currently do, but they're also at the same time going to carry a DC level. So you don't the wiring is
It's not a separate wire. It's all part of
not a separate wire. We run audio plus carrier on the same differential pair that you currently have for just audio.
Got it, because that was one of my partners that was calling me when my phone went off, and I was telling him about this topic. I'm going to send him the video once Barry posts it, but because we have 2 AM1s down there, and he's complaining about the electric bill on an AM1. So
yeah, well, I could save $500 to $1,000 on a 1 kilowatt. So,
is there any price set up yet on these units?
there is, and maybe Rich can answer that
Yeah.
question.
Generally they're well, we kind of had a show special going on that, if you went pretty quickly, you probably could take advantage of, which was, I think, $2,500. It's normally around 3,000 or so. It's less if you buy it with a new transmitter. If you're adding it to an existing one, it's a little bit more, but
Okay.
yeah. So on most of them, the payback's pretty quick.
Okay, yeah, I had a stroke, so I didn't go to NAB. So, okay. Very good. Thank you, guys.
Thank you. Great to have good questions.
I don't know, what other questions anyone has for Tim or I regarding this? I think the comments that Ben had earlier, I think are important, which is, depending upon the allocation and where you might have co-channels, right, may indicate that you might not be able to use this quite as much. Now, the one thing that I will say is, right, the whole premise here is based on if I have relatively dense and loud audio, I can turn the carrier down more. And
Rich,
so, yeah.
You just
Yes.
made the very important point, which is that no one should be running MDCL without running really good quality audio processing.
Yeah, exactly. Because that's kind of the basis of it. So, if you're not running, and when I say competitive, if you're running a 40-year-old Optimod 9000, that may not be sufficient, or you're running it very light. I'm not saying you have to go get a brand new audio processor. For sure, there are lots of benefits to that in and of itself, but that's not what we're saying. But it should be noted that you have to have good, loud, dense audio to get the maximum benefit of MDCL. If you're not running dense audio, you won't be able to have as aggressive savings.
We've had a couple of instances where people were complaining about fringe area problems and replaced their audio processing, and the complaints went away.
Yeah, for sure. There have been some developments more recently, and I know guys like the vintage sound of certain boxes, but this is a case where, especially with MDCL, there's a pretty direct correlation between the power of your audio processing and how clean and dense your audio is, with the kind of benefit that you get, especially if you try to go above 3 dB, right? There are some guys who like to claim enormous savings, but it's kind of like, well, the caveat is I bought a brand new transmitter and I bought a new Optimod. They're great in and of themselves. I'm not saying they're not. It's it's just you need to be cautious that your combination of audio processing and how aggressive you want to run the MDCL. You can have cases where the fringe coverage area, you go, geez, this doesn't seem like it's a free lunch. I'm losing out. It may very well be the audio. Now, other things anyone might have?
Rich, Tim, would you like to put up a card here on the screen with contact information?
I don't have a slide like that, Barry. The simplest thing is just go to the BE website, bdcast.com, and there's a contact us form, and we'll follow up with you. That's probably the easiest for everyone to remember.
Hey, Rich.
Yeah.
Hey,
Dave.
There's no noise sent from the box going through since you're introducing the DC into the audio input. There's no noise at all.
Tim, I know we ran audio tests on that. I didn't remember seeing an increase in any sort of audio noise.
No, the audio processing is actually just analog processing. So it's running through a couple of op amps basically, and there's a gain adjustment through a DAC. So, it's certainly minimal. We did tests of it in sort of through mode, and the audio levels, the signal noise, that sort of thing really wasn't affected.
Well, you mentioned that it's going through. How low a level is the noise that if you there's got to be something
for AM transmitters. 70 dB is the number for signal noise that we always try to meet for AM.
Okay.
And that's kind of what we're trying to shoot for.
Thank you.
Sure. Well, Barry, we appreciate the opportunity to share with the group here today, and everyone having kind of an open dialogue. It's always better than just 156 slides and us droning on.
Well, that's true, and we're glad that you came between YouTube and Zoom. Here we had something in the mid 40s live,
Great.
and we're going to have a whole bunch that watch on the video, which I should be posting tomorrow.
Awesome. Well, thank you, guys.
So we sure. Sorry that I'm looking for a card here right now. That same phone number for years, 217-224-9600.
And now that we fixed the fiber, it'll actually ring in.
Oh boy, that's a real winner when the phones don't work. So what are you going to bring to us next, Rich? The quick blocks are working out pretty well, are they?
Yeah, we're making good progress on those. I think we've got some lower power units have kind of been the first to come out, and then the higher power units are coming. The new digital exciter, we should start seeing that rolling out this summer. We're pretty close to done on that, and then I wouldn't be surprised if you didn't see we're kind of embracing the software platform for HD radio importer exporter, which allows you to, if you so desire, you want to use software audio processing for HD 1, 2, or 3, or analog for that matter, right? It allows some interoperability there. And You know, so those are some things. I guess, you know, the other thing I would mention is that, you know, on the Audio Vault side, we've recently completed tests with the Angry Audio guys to use their professional USB audio interface, which has really great performance and is quite cost effective. You know, we've kind of felt for some time that in some cases, some of the PC sound cards are fairly pricey for what you get, and so we think this is a good alternative for folks. So, you know, we're trying to make, you know, investments that help lower people's cost to deploy technology with something that's, you know, robust and reliable and of pretty good quality.
Do I understand in a way then that BE is reaching out to spread out the product lines a little bit?
Yeah, you know, probably a little bit. You know, we had discussions, I think, previously about our we revamped the radio experience TRE with our web-based platform TRE Plus, and I think I saw a list the other day. We've got a couple hundred users on the new platform already, which is nice. And so yeah, it's kind of, you know, the different areas we've been in for some time. It's just kind of branching out the offerings.
Well, it's interesting. In the old days, of course, BE could supply everything from the input console to the transmitter, and it kind of slimmed down over the years, and now you're building back out, which is, I suppose, partially from the L&O side, or just
Yeah, it's, you know, a little bit of everything. Some of it is just partnering, you know, for technology deployment and you know, expanding our footprint. Others, like I mentioned on this with MDCL, it started with a conversation at breakfast about what's a challenge you guys have and what's something you haven't been able to find. And like I said, kudos to Martin Stabbert, who said, hey, here's a solution I'd be looking for, but nobody has it. So you know, we do try to pay attention there. You know, to your point about having a little bit of everything, I was cleaning up some stuff in my workbench at home, and I found in one of those little things that have all the drawers, I still have, I think, one or two pinch rollers from a Phase Track 90 that I used to take care of. So, because if somebody's hell bent on finding a dried out pinch roller for a Phase Track 90, I may have one.
I think I have 3. Maybe we
So
should give them away as a door prize.
we could
When
indeed do that. Yeah. Yeah, the pinch rollers may be a little small for the doorstop, but for sure the cart machines make excellent doorstops.
Absolutely. Got a 1070 here. At least it's still operating.
So again, thank you, everyone. We sure appreciate the opportunity to participate, and thanks for the great questions.
Well, thank you, Rich. Thank you, Tim. Really good to see both of you.
Thanks, everybody. Great
Thanks,
to see you.
guys.
Bye now.